Right, just give me a minute. Right, up until I better go to X-ray view. It might be easier. Oh, I'm not highlighted. Hang on. Right. At the moment, the device that we've been working on is basically a coil on one side and a coil on the other side of the concentric magnet assembly. The concentric magnet assembly, which has 6 pole magnets, 3 of which are south pole, the other 3 are north pole, and they alternate between north-south, north-south. And when I think I'll take X-ray back off again. Actually, it's not helping much. So we have laminations, but this is the older model on this particular 3D model that we're using. But there's actually as I showed in previous videos, there's some laminations which go through in the shape with a V cutout basically in the centre. The V cutout basically is in the right in the middle of the assembly, so that gives like a shunt, so that the magnetic field can be deflected, so that when the H bridge is sending the AC pulses into the coil assembly, what happens is that the south pole is first extracted from the magnetic field. So the south, I think I said south, yeah, south field is pulled out this side and the north is pulled out of the left side, and then on the other cycle, the other half phase, it's reversed, so the south is on the left side and north is on the right side. I'm sorry, I'm getting mixed up because yeah, it's confusing. But what I've been thinking about is how to minimise the input current. Now, because I'm using 2 coils, well actually there's 4 coils, so if I just back out a bit, we've actually got the coils at the top section, and we've also got coils at the bottom section. That's 4 coils total, and they're all wired. The two at the bottom are actually wired in series. The 2 at the top are wired in series, but the top and the bottom are in parallel, which increases current. And I'm pulsing at about 33.5 volts at about 60 microsecond per cycle pulse, which is positive cycle 60 microsecond, a negative cycle of 60 microsecond. So we're using capacitors across these coils of about 1 microfarad metal film, and those capacitors basically store energy from the pulse, which smooths out and overcomes any labour that's translated onto the input side of things, so we don't actually see the excessive current load, because the capacitors absorb that, and then that's stored in the capacitor for the next cycle, which is, so it's assistive to the next cycle. I wish I could pause this, but yeah, I need to use the bathroom. Just started to do this video. Well, I had a breakthrough. I had a bit of a brainstorm. I'm just going to give you a teaser. We're going to do away with one of the coils. I should be able to finish this actually. Instead of having 2 coils on each side of the actuator magnet, why don't we just have 1 and put it right in the middle? So that's what I'm doing. So this here is the next phase. So instead of having the laminations which I currently have on the outside of the bobbin, which actually intersect with the inner core material, actually they're not actually technically on the outside of the bobbin, actually they're actually inside, they're actually near the ferrite cores that go inside the bobbins. But what I thought about was, let's move everything inside the actual magnetic field, so that we're basically in a magnetic bath. So what we have then is this situation. We have north, south, north, south, north, south, and what we have, this is the, let me just edit component, let me just, I want to actually just unedit that. Let me just hide this a minute, hide half of the bobbin so you can see inside, so you can see what's going on. So I've hidden half of the bobbin. So what we then have is we have our coils around our bobbin, and the magnetic field from the static magnets which is on the ring, the field passes directly straight through the bobbin coils and everything, so that there's a massive saturation of magnetic flux right in the centre there. And most of the flux is simply cancelled out because we've got north south, so the north will be cancelled out by the south. But when the coil is actuated, what happens then is both fields are flipped away from each other. So what happens then is we have north going out the left side, we have south coming out the right side, and that flux is induced into the the steel laminations, which sit in these little slots. So this is the new insert which goes in the middle. So the steel slots are basically resonant pieces of steel that resonate with the frequency that we're using, which is basically around, I've forgotten what it was now, 200 and, is it 200, what was it, 200, I think it's 2.6 kilohertz, 2.7 kilohertz. I think, yeah, we're at 2.7 kilohertz at the moment. So obviously the frequency will probably change because everything will be much closer coupled. So we'll probably see a higher frequency because of that. I can't be too sure until I actually test it, but I anticipate that we'll have to be running at a higher frequency, maybe. And it'll also help to get rid of some of that lag that we're seeing, because you see when they've got the coils on the outside, so the coils are on the outside of the magnetic assembly. The problem with that is we have lag in the material, the core material that goes through to the steel laminations. We have a bit of lag, so when you get this big pulse, it's quite a sharp pulse, and it's pulling on that magnetic field. The magnetic field has to switch very quickly, but it can't switch all that effectively, so we've got some losses there. Obviously a phase shift is an advantage. You have to excuse me a minute, I'll be back in a minute. Dear me. Sorry about that. I had a problem with my stomach. Let's just leave it at that. Right, so where was I? So, well, what we've got now, I did think about this a lot previously. There's only so much you can get inside here because of the space constriction, and obviously the smaller the diameter of the core material, the less core material you can get in there. I mean, the width of these cores, these little inner cores, is I've actually printed some out. I could measure it, but they're basically about 22 millimeters wide. So 22 millimeters is not a lot of space. So these laminations we can only really get in. I've had to extract one lamination, that's 1 millimeter, off each one of these because there was going to be overlap on the intersections there, and this little hole in the middle is in case I need to add a ball bearing or something, like to attenuate for the tuning, to add more physical mass, or a screw even. You could stick a screw in there or something, but the idea really is it's a tuning bit, and believe me, it makes a lot of difference. It does actually make some difference on the resonant frequencies between when you've got two of these coils, one at the top and the bottom. By having more mass in one, it creates more of a lag on that particular one than you might have on the other one. So if there's two of these, by adding a bit more mass into this one, it's a bit like a tuning slug on a radio, because we are working at about 2.7 kilohertz, so it is technically a radio frequency. So yeah, so anyway, I thought I'd show you this idea and this new design that I'm working on right now. There's not a great deal of difference. I can still use existing coils. I can just swap my coil. Instead of having two coils on each one, I'll just have one, and that should eliminate a lot of my input current, because the coil is going to be immersed in the field. I predict that there will be less workload, because the equilibrium of the fields are simply switching places. They're not technically being moved around a great deal. So the fields that are coming out, on one cycle it'll be north on the right, south on the left. On the other cycle it'll be north on the left and south on the right. So they'll alternate. So we have a resonant frequency, and it is basically the same thing that's going on already with the device that you've seen running, but we're just improving we're immersing the coil in the flux itself instead of trying to pull the flux out of a tight ring. Instead of extracting flux from this tight ring where it's all been pulled together, we're inside the flux field, so we're expelling it instead. So there's a slight difference. Instead of pulling the flux out, we're actually expelling it. We're basically pushing it out instead of pulling it in, sort of thing. So there shouldn't be a great deal of difference. It should actually be a lot more efficient because of the fact that we're actually immersed in the flux. So every single winding that's on the coil will have an interaction with the magnetic field that's in there, whereas when the coil is on the outside, like this existing one, the problem is we're pulling the flux along the inner core, which is down. Oops, I can't get there now. We're trying to pull the flux along the inside core material, so there's going to be greater losses, because a lot of the flux, all the flux is coming down basically down these pipes of steel. Well, they're not actually technically pipes, but if you get what I'm saying, it's like pulling it down the pipe, but it's pulling it down the steel rods, and so there's going to be more loss in this one. So because this one with the bobbin right inside the flux, there should be a lot less loss, and we should be able to shape the field a lot more effectively. So anyway, that's the idea. Anyway, I've waffled enough. I think, sorry about the big gap. I'll probably go in later on and cut that bit out where I disappeared for a while. I don't know how long it was. I didn't really time myself, but yeah, we'll see later. But that's what I'm doing at the moment. So I suppose I can unhide that bob in half now. Oops, there we go. Right, I've just undone it really. So anyway, that's the next stage. Anyway, I hope you enjoyed watching, and some new inspiration came to me, and that's where we are now. It looks a lot more concealed. I know it looks a little bit what's the word, naughty, because it's hidden. The coil is inside the coil, but no, it's not. It's just the way we're talking efficiency, and obviously this is why I'm explaining it to you now, because it's hard to show you this later on, because unless you actually know the coil's inside there, you probably wouldn't notice it was in there, but that's where it's going to be. I've done some measurements on the dimensions, and the coils will definitely fit in there. Well, I certainly hope they will. Anyway, if they won't, I'm just going to have to do a bit more sandpapering or trimming or whatever, but they should fit in there. I did some measurements, and there's no reason why they won't. Anyway, I better go before this stream gets ridiculously too long. I'm going to have to update my 3D model, because obviously we're changing all this core material on the secondary stages, which is no longer the steel, which is now the nanocrystalline core material. These models are all reflecting on the old stuff that I put in there, so it's kind of obsolete, but it doesn't really matter. The actual updated model parts, well, they're over there actually. They're in here, but they've just not been integrated into this section here. They're actually over here. These are the new ones that I printed out. So they're actually in the model, but I just haven't integrated. Those are the original ones with the steel laminations. I had laser cut. These are the new ones. I didn't bother drawing up more of these brackets. I just use the same brackets. I printed them out again and just put them on there. Yeah, actually that's the beta version of it. The later version is, where is it? Almost. Oh yeah, I know why. I know we can't find it. It's because I actually put it in a different drawing. Let's just go to that a minute. I'll just save that. I'm waiting for the hourglass a minute. You see, this file was getting too big. That's why I decided to create a new file, because it just takes, when you every time you save it, it takes forever. So the new one is in here. Should open a lot quicker. So there's the actual new insert, and these are the new. Yeah, these are the updated new ones with the brackets and everything. Same brackets. So these are the ones which I'm using with the nanocrystalline core material in them, and there's actually covers that go over the top, but you won't be able to see them at the moment because they're actually hidden. You can see them when I show hidden material, you can see it's there, but yeah, right, I think that's it. I've updated you on the new plan of action. Stay safe, and yeah, I've already said Happy New Year in previous videos, but yeah, I don't think it's going to be that good actually, to be honest with you. With this virus around, it sucks, doesn't it? Yeah, okay, right. Oh my god, what happened to my thing? Right, my previous screen's gone blank. What the hell's that all about? A minute. Oh, it's still there. Right.